Okay, hi everyone. I hope you've been having a great start to this conference, to the virtual part of the conference at least. Already, I know I did. And welcome to my session about deploying generative AI models. My name is Anouk. I work as a product owner at UbiOps, and my background is in nanobiology, computer science, and game development. And I wanted to talk to you a little bit today about some best practices and an interactive example when it comes to deploying generative AI models. Now, I already mentioned that I work as a product owner at UbiOps, so I very briefly wanted to tell you a little bit what UbiOps is, just so that you can put my talk into context of my experience, so to say. So UbiOps is an MLOps solution for deploying, running, and scaling AI and ML workloads, and I will also be using that for the example part of this session, so then you know what it is. We're really mainly focused on deployment and serving at scale, but we also recently added functionality for training and experiments. But that's really all you need to know about that. Let me skip to the interesting stuff. This is the schedule I had in mind for this session. So the introduction we already had. I wanted to start off by talking a little bit about deploying to production in general, before moving on to these actual best practices when deploying generative AI models specifically. And in this section, I will pay special care or special attention to hardware options and how to choose what hardware works for you. After that, we'll have the workshop or the interactive example where we will actually deploy Stable Diffusion together with the use of a Google Colab. Of course, you're more than welcome to just watch me do it as I go through the steps. The Google Colab link that I will share with you later will remain available after the conference as well, so you can revisit it anytime you want. And you're, of course, also more than welcome to join along with me. And at the end, we can wrap up with a small Q&A. You're more than welcome to put questions in the chat as I go, but please note that I will not be able to see them as I am presenting, so I will probably only get to answering them at the end. Sorry about that. I will try to shoot a glance in that direction in the meantime as well a little bit, but just so you know, if I don't answer, I will definitely get to it at the end of the session as well. Okay, so let's just get started with deployment in general, deployment of machine learning models. I like to refer to this as getting machine learning from the lab to the field, to a place where it can actually start generating value for the business. Because typically when you start on machine learning applications and you really start with the implementation side, you start with writing some Python code on typically a local laptop. And this is all fun and games, of course, but at some point this will need to move to a production environment where it can actually be used. And that step, that can sometimes be a bit of a hurdle. And you might be surprised at this because you've come to this Toronto Machine Learning Summit and you probably know already a lot about MLOps, but I very frequently still get the question, what is the issue with just having a machine learning model locally and just running it locally? Of course, running a local model that needs to be run let's say every quarter is perfectly fine if that's a manual step, but most use cases will not be something that has to run so infrequently, and typically will need to be deployed either behind a web app when it's external user facing, or it needs to be accessible to non-technical people who cannot run Python themselves. So it needs to move to a specific environment. Some of the issues of keeping it locally will be that it doesn't have access to the right data. Typically, you only have access to a subset of the data that you trained on and not necessarily production data. Resources, do you have the right resources? Especially when we're talking about generative AI, you typically need specialized hardware that you don't often have on just a regular laptop. And scalability, as I said, once every quarter might be fine for manual, but what if you need to handle 100 requests per minute? Then you can't really do it manually anymore, and it needs to be an automated process. So typically what I personally see, at least in the Netherlands where I come from, is that the plan looks something like this. Okay, we start with this piece of code that's either in a notebook or maybe in a Python file, and we'll cram it inside a Docker container and we push it to the cloud and we're there. We've got value for business. Now, in reality, that cloud and that Docker part has a lot of individual components related to that, varying from things like source control, what kind of cloud to pick, different data sources, a combination of local servers and cloud servers, some Tableau dashboard that it needs to be hooked up to, not to mention the headache of Kubernetes. MLOps is really a vast landscape at the moment with so many different tools, both open source, closed source, all needing to work together to get through that path. And it can be quite overwhelming. And I think a lot of people in our field also kind of suffer from decision fatigue with so many different options, and how can you even bring everything together? So in reality, this process can be quite a hurdle. And that's something that we also noticed. UbiOps actually started about 7 years ago as a data science consultancy initially. So we made data science, mainly predictive maintenance applications for other companies. And we noticed this hurdle time and time again. So we started working on a way to make it a bit simpler. In a first instance, just for internal usage, and about, I think, 4 years ago now, maybe 5 already, we made this public. And this is really the part that we focus on trying to make this a bit better. And from that standpoint of having looked at how can we improve this, there are a couple of things that I wanted to share with you that I think you should really consider when you start this deployment process. First thing is that regardless of what kind of tool you use, open source, closed source, internally made, something that you buy, doesn't matter. I think it's really imperative that your deployment process is easy, so that iteration is also easy. Something that I see a lot is that the deployment process is very cumbersome and not really standardized in a company. And because of that, iterations get vastly delayed. And I think we all know that when it comes to data science, iteration is really key because your data is continuously changing. So that means that also your model performance is continuously changing. And especially when we're talking about things like Gen AI, when we talk like ChatGPT, it continuously needs to be refined because we find out that for certain prompts, it gives very bad results, for instance. And if the deployment process is easy, this will make sure that those iterations happen quickly because there's no hurdle to making them. And if it's cumbersome, your deployment process, iterations will lag, and this will snowball effect into very poor performance quite quickly. I also want to urge you to consider using shadow deployments. For those of you who don't know, shadow deployments is a technique where you deploy a model kind of in the shadows, where like an end user will not see that that model is running, but you just log for yourself, like, okay, this was actual like production input. This was the output that the model gave. Is that something we really want to push publicly or roll out like fully? Does it perform as we expect it to do on production data? Because very often you can see with machine learning models that they perform very differently on a test set or a validation set than they do on actual production data, because production data continuously changes. So shadow deployments, I think, are a really good thing to use to get an idea of what the performance will be in a more reliable way than just testing it. Also consider what the data traffic is that you expect and make sure that you have the option to scale out accordingly. Data traffic is something that typically is very application dependent or company dependent. Some companies will have to deploy their models behind an app that will be used worldwide by many different parties, and they know it will need a GPU, for instance, so that means that they will need to scale up to X amount of GPUs at any moment to be able to give a response in an adequate time. Because especially when you're thinking about like customer facing things, you really want your response times to be small, because the longer they are, the more likely your user is going to think that your app crashed, and you can't have that. So thinking about that data traffic is very important to make sure that you choose your hardware and your settings accordingly in a way that you can scale out to the maximum traffic that you expect. If your maximum traffic that you expect is very constant and very low, that makes stuff easy. The more unpredictable it is, the more difficult this can become. Also ensure that model versions can safely be updated without needing to update all the API endpoint references in every tool that you're using in your stack. Something that I see, for instance, is that some people, when they deploy a new model, they create a new API endpoint for each model that they deploy. But that means that every tool in your stack that uses that model will need to be updated to refer to that new endpoint, which is very cumbersome. What I like to use is something called a default endpoint, where I have one standard endpoint per model. And it doesn't matter what the application is behind that, or what the version of my model is that's running behind that endpoint. The endpoint stays the same. It's just the implementation behind it that changes. Okay, but so much about deployment in general. I wanted to talk about generative AI deployment, because what changes when you're talking about generative AI models than when you consider like more regular models, like a more typical linear regression, for instance. I would like to categorize generative AI as follows. So as a type of artificial intelligence system capable of generating text, images, or other media in response to prompts. So this means that I'm only going to consider the ones in response to prompts, and I'm just going to park the ones for now where you, for instance, enter video and it does something with that video, because that's a little bit of a specific niche branch, and I think this one is a bit more the standard. And these are almost always neural networks. And they have a general structure, which is very similar to deployment of any model, really. A lot of things are the same for deploying any regular machine learning model. The main thing that differs because of this categorization that I made is how it's structured, that the structure is always the same. So there's always this text-based prompt that will come in, that will go to your API, which has a piece of Python code running behind it. And it will return some type of output. And that output is almost always a file or text. So when we talk about something like ChatGPT, of course, it returns text. So that can be simple string output, or to a text file if it becomes longer. Or when we're looking at things like Stable Diffusion or Midjourney, these are images, so they're files. And this can be sound files, image files, video files, those kind of things. So this structure is still very much the same as just deploying any machine learning model. But I think that the biggest hurdle is really that it often needs specialized hardware. Generative AI models have a tendency to be very big neural networks. And if you would deploy them using just standard purpose CPUs, the inference time can become so long that it's unusable. For instance, when you deploy like Stable Diffusion, which we'll do a bit later on CPU, this can lead to a request time of like several minutes up to half an hour, whereas on a GPU, it can be done in like 10 seconds, which is already a lot more user-friendly. But then that, of course, opens the question of even what hardware should I use for that model? How do I know which one is the right one for me? Because there are a lot of different types out there. Like CPU is, of course, a general purpose one that always will work, but it might be very low on performance. But then all the specialized ones you have, you've got GPUs, you've got IPUs, you've got TPUs, and a bunch of others still as well as specific specialized clouds. But I wanted to focus on these three for now because I think they're the most common ones. Now, unfortunately, there's no cookie cutter answer of, oh, my model is X, so I will need to use Y. And there are always trade-offs to be made. So what I hope to do in the next couple of slides is give you a little bit of an overview of the pros and cons of each, what they're made for, and some questions to ask yourself to hopefully help you choose what works for you. So let's start with GPUs. So GPUs, they were made for graphics processing. So that's really what they're very good at. And of course, machine learning and deep learning is not necessarily graphics processing, but it has a lot of underlying things that are the same that makes GPUs lend themselves well for these applications. Because they're highly optimized for parallel processing of small calculations. And they work very well with big batches. And in the end, neural networks are just a lot of linear algebra, so that fits well on the GPU. And you've also got some specific types of GPUs that are specifically well suited for inference, like T4s, NVIDIA T4s, I mean them. But the downsides of GPUs are that there are so many different types of GPUs to choose from, and there are new ones being brought out like every year continuously. It's very hard to keep up with, especially if you're investing in GPUs to like really local GPUs to keep in your office. They can very quickly get outdated, that they don't provide the right performance for machine learning, because the field of machine learning is very quickly evolving. And each type of GPU has its own quirks, its own pros and its own cons, typically cost related and performance related. So that can make the decision there also a little bit more difficult to find the one that works best for you, because like an NVIDIA A100 is very different from an NVIDIA T4, for instance. Also, something that I wanted to mention, which actually kind of holds for most of these, is that they use a lot of energy. So if sustainability is like an important point for your business, this is definitely something I think you should consider as well when picking hardware, that the more energy it uses and the longer it needs to run on something also directly relates to the bigger climate impact typically. Also, it's built for general purpose because it's built for all types of graphics processing and not specifically for machine learning. It's not as optimized as it can be, which changes when we look at something like IPUs. So IPUs are intelligence processing units. They are made by Graphcore, and they are really made specifically for deep learning. They've got efficient, massive compute parallelism, very large memory bandwidth, especially when we compare it to GPUs, and they're specialized for graph processing. So really like the graph calculations that you find in a neural network. Downside of this is that they are only available on specialized clouds like Gcore and Paperspace, and as far as I'm aware, they're not readily available on the major clouds. And therefore, they also have less availability. So if you need a lot of them, if you need to be able to scale out very rapidly, this might not be the best choice. And GPUs might be a safer bet to have more of. And then lastly, we've got TPUs. TPUs are tensor processing units, which are made by Google specifically. They used to use them internally, and I think a couple of years ago they made them public, that other people can also use them. And they're just like IPUs, highly optimized for deep learning. So where IPUs focus on graph calculations, TPUs focus on tensor calculations specifically. Other nice benefit of TPUs is that there are lots of reference material for how Google uses it for their application, so that can be very useful. Some of the downsides, though, is that they're generally much more expensive than GPUs because they're so highly specialized. So I would personally say when it comes to TPUs, only use them if you really, really need them to meet your performance criteria, or if you just have too much money to spend, then sure, go ahead. But I think most companies are, of course, restrained in certain budgets that they can use. So it's definitely something I need to note, that TPUs tend to be a lot more expensive than GPUs. Tensor calculations only, so that means that they work for PyTorch and for TensorFlow, but not necessarily for everything. For generative AI, that shouldn't be much of a problem because most of them will be created with either of those two libraries, and they're of course made like generative AI is almost always a neural network, so that should fit. And the last downside is that they're Google only. So they're really only by Google. They're not available on other clouds. Although at AWS, you've got an alternative, which is called AWS Graviton. It's quite comparable. But as far as I'm aware, there's not an alternative on Azure if you're working with Azure. So that's also something to take into account, because I know that some companies have regulations that they're only allowed to use specific clouds. Okay. Now, some contributing factors for your decision, some things that I think you should take into account. I think the most important question to ask is, what is the desired request duration? Does it need to be below a certain limit? Sometimes we get customers coming to us saying like, okay, we know we need to use heavy hardware and that's required, but we need to get this request duration to be max 1 second, for instance. And that can already limit your options because certain things won't be able to give you that desired request duration. So if you start with a question like that, that already makes your scope of possible selections a lot smaller, which I think can help. Because if you do not start with this question, you can end up in a scenario where you're like, okay, I want to use this kind of hardware, but it will never be able to give me the performance that I actually need. But at the same time, it can also open up your scope of possibilities, because if you say, well, just an internal model that can run on the background, it's fine, it takes like an hour, then it of course opens up all your options again and gives you a lot more freedom in terms of what you can choose, so that you can also look a bit better at things that are more cost effective, for instance. Second question that directly ties into that, of course, is how much budget is available? What can you play with? Can you actually afford better suited hardware or more memory allocation? Or are you restrained to only use specific types of GPUs because others are not available to you? How big is the model? Does it need a lot of memory? Memory is one thing that you can typically tweak quite a bit. And it can be nice to make sure that you optimize your memory allocation for how big your model is. So if you've got a big model and when you make a request to it and you only use 20% of the memory allocation that you have, that's a lot of extra costs that you don't necessarily need to make. So you want to get your memory allocation as close to like your peak memory consumption as you can get to be most cost effective. How's the performance on CPU? It might seem like a weird thing to put in here because surely generative AI will not be fine on CPU, but I do think it's always a good thing to check because CPUs are the most abundantly available, the cheapest, and the easiest to work with. So if it can run on a CPU, I would always say just run it on a CPU. If it gives a fine request duration on CPU, go for it and don't bother with the specialized hardware just because a lot of people are claiming that specialized hardware is the way to go. Definitely stick to the basics if you can, because sometimes that's just better. And of course, it's also important to look at any regulatory constraints. So I already noted that some of these hardware types are only available in specific clouds. And that's something that really impacts your selection. So always make sure that you look at, okay, what do I really need to look at and what is available specifically there, rather than looking up articles on, oh, the best type of hardware to use for this type of model, and then just to find out that you actually cannot use it on your cloud. And how much do you need to be able to scale out? So that's actually the same as for the general deployment that I already mentioned before. So in the end, when you combine all these things, I think it comes down to this kind of triangle of cost versus availability versus performance. And it's almost impossible to get all three. So I think it's important to make a prioritization of which of these are the most important to you so that you can get to a selection that works for your criteria. And that might mean that sometimes you will have to give in a little bit in terms of performance, but therefore gain a lot of cost benefits, or the other way around. And this is really application dependent. So that's also why I said I cannot give you cookie cutter advice, but I would really put those down for yourself, see which are the most important for your specific application, and try to use that to kind of minimize the scope of what you can select from to make it a bit easier. Of course, it's sometimes very difficult to pick the right one right from the start, and that's perfectly fine. Just run a benchmark. There are a lot of trials available, either on the general clouds that you can use some free credits to test some things, or with UbiOps, we also offer some trials where you can just evaluate a bunch of different hardware options and settings to find out which one works best for your model. And just try to find the optimum one before you stick to it. And of course, also continuously evaluate. It's important to really evaluate also after you have deployed a model to see if your settings actually work, or maybe in the end, the usage of the model is a bit different than you anticipated it to be, and you can change your hardware settings to one that's maybe more cost effective, for instance. Things that are important to look at here, I would say, are things like memory consumption, GPU usage, and general traffic to your model. And last but not least, code optimizations are equally important. Up to now, I've of course mainly talked about hardware options, but you can do a lot with your code as well. There are a lot of frameworks and tools that can help you to optimize your code so that your code alone, regardless of what kind of hardware you're using, already runs faster. And things like TensorRT can really help here from NVIDIA, and NVIDIA has a couple of other frameworks if you're using GPUs, and they can really significantly speed things up. I linked an article here below. I will not go into the details of it now, but if you're interested in the effect of using TensorRT for different kind of GPUs, have a look at the article because we made some benchmarks so that you can see if you can maybe use TensorRT, if it will pay off for you or not. Okay. That's all I wanted to tell you in terms of like general information. So let's look at an example where we can actually deploy Stable Diffusion together, because that's what we're going to build today. So in this way, in the end, you will have or let's first maybe mention what Stable Diffusion is. I think most of you are familiar with it. Stable Diffusion is a latent text-to-image diffusion model capable of generating photorealistic images given any text input. So that will look something like this. So you've got the live Stable Diffusion model on UbiOps running behind an API, and we can send input to it in the form of a prompt. So here, for instance, I've got an example where I send in dragon, hyper-realistic sitting on a throne, and our output will look something like this. The Stable Diffusion model is taken from Hugging Face. I also opened a poll a little bit earlier in the Hoova app to ask how many of you train your own generative AI models or use from Hugging Face, and I saw that most of you actually pre-train one from Hugging Face. So hopefully this will also give you a little bit of an idea of how you can deploy them. Let me throw a quick glance at the chats. How does UbiOps compare to other MLOps platforms like Kubeflow, MLflow, Metaflow, etc.? Good question. So I can go into this a little bit more at the end. Main difference is in, let's say, availability of hardware. So we are set up to work in a hybrid cloud setup as well as into a single cloud setup while having like this unified interface. It's a bit higher level than Kubeflow, for instance. Kubeflow is very low level. You need to have knowledge of Kubernetes to work with it. While UbiOps runs on Kubernetes, you don't necessarily need Kubernetes knowledge to work with it yourself, and it becomes easy to couple different node pools that are, for instance, in different cloud environments to one project, so you can run from there while not having to fuss with Kubernetes yourself. But that's the main difference with Kubeflow. A lot of the concepts are kind of similar, but it's a bit more geared for a data scientist to really work with it rather than only an ML engineer or DevOps engineer to be able to work with it. So I would say that it's also the learning curve, but that's, of course, I'm biased there. With MLflow, we've got actually a lot of customers that use MLflow next to UbiOps because some things overlap, but some things are also very different. So MLflow is, of course, really focused on mainly experiment tracking and trying to find the best model and having like this model catalog, where UbiOps is really mainly concerned with really that deployment part. I mean, even though we do some of the experiment tracking stuff as well, we're really focused on deploying at scale. And deploying in different clouds. And MLflow, you always have to run your own MLflow server. You need to be able to set that up. UbiOps can either be used as a SaaS, where you just create an account and go, or it can also be on your local premises if you want that. Metaflow, I'm not completely up to date on Metaflow how it is, so I won't be able to judge that too much. I'm sorry about that. I see that some other questions are coming in. I'm going to leave them to the end of the session because I think otherwise I won't be able to finish probably like in a good time. Just quickly about the copy of the slides, definitely. I'll have to check in with the organization how it works. I know that the recording will definitely be available, and I can just share the slides. If it won't be through the organization, then just send me an email. I'll have my contact details in the end, and I'll gladly share them with you so you can look at them later. Okay, going back to the example of deploying Stable Diffusion on UbiOps. I hope that also will like by doing the example, might also actually answer a couple of the questions because you'll be able to see how it works so that you can make the comparison in your head of tools that you've worked with before, maybe. So very shortly about the architecture of UbiOps so that you know kind of what we will be doing, because we will be making something that we call a deployment. And a deployment in UbiOps is basically little microservice with its own API endpoint that you can send requests to. And these run, or these can be controlled via what we refer to as the UbiOps control plane, basically our interface, that be via a Python client library, via the command line interface, via the web app. However you want it, you can control these microservices, scale them up, scale them down. And the scalability actually goes automatically because we run on Kubernetes underneath. You won't have to have any knowledge of Kubernetes for working with UbiOps. If you do, it always helps, of course, to know what kind of settings you can tweak, but you don't need to be bothered with Kubernetes for using UbiOps. And by using Kubernetes, we make sure that we allocate the right compute resources to each model. And all of that can run either on the cloud, like either via our SaaS that we manage everything, or it can be in an environment of your choosing, so that you say, oh, we want it specifically in our Azure environment, for instance, or even on-premise and in a local data center. We work for the Dutch Cybersecurity Center, for instance, and as you can imagine, that's a completely air-gapped system. So we've also got some experience there. And what did I want to say? Yeah, so we're going to make a deployment here. And for today, I'm going to use the client library because that's easier to share with you via Google Colab. Of course, everything that I'm going to show you can also just be done via the UI, which you can see here. More bit about that later. Or there you go. This is the UI, for instance, the web app or the command line interface. But I think for now, the Google Colab is a bit the easiest to follow, because then you can also follow it along at your own pace yourself later. So let me go back here. So without further ado, let's get started. If you want to follow along, this is what you need. You would need a UbiOps account. You can create one at app.ubiops.com/signup. Let me put that link in the chat as well. app.ubiops.com/signup. So that's where you can create an account if you want one. And the next thing you need is the Google Colab notebook that we're going to use for actually deploying the model. So let me share that link for you as well. In the chat. Okay, so that short URL that I just put in the chat, that's the one that links to the Google Colab. You should all be able to run all the cells yourself. So that should work, hopefully. If you have any problems with that, let me know. There might be this pop-up and at first saying, like this Google pop-up saying like, oh, this Google Colab is not made by Google. Do you trust it? That's just an announcement you get for anything that's not Google made. So don't be scared. I will not try to hack your computer or anything. It's really just for making a deployment. And you can just safely say, yes, trust this one. Okay, then let's see. I'm gonna switch my tabs first to the web app. So let me go full screen quickly. I hope this is all viewable for you. Let me zoom in a little bit, so hopefully it's a bit better to see. Okay, so when you create a new account, you'll first enter the organization page. So this is like where you will go when you create your account and you log in for the first time. Please note that when you make a new account, there will be an email to verify your account or to activate it. You have to do that one before you can log in again, but that should follow itself. So upon sign up or the first login, you'll be prompted to create a new project. You can name this however you want, and then you will see this page. Then you can go to your project, so you should be able to see like your project tile after that. Like I've got these 4 here. So let me go to my demo project quickly, and you should see something like this, although everything would of course be empty because you don't have anything yet. And that's basically our starting point from where we will go. Because what we will do is we will create a new deployment. You could do this via the UI, but we're going to do it with the Google Colab. And to be able to do this using the Python client library, we need an API token to set up a stable or a secure connection to your project, so that you can actually make calls using Python code and make sure that everything ends up in your project. So to get an API token like that, if you're on the web app, if you're in your project, you can go to project admin, which is the last one in the left menu, and go to permissions. Here you will find a tab called API tokens, and you can click add token to create a new API token. You can give this one a name. So let's say TMLS demo token. The other fields you can just leave for now. You don't need them. I can go to the next step. And then you need to say, what role does this token have? Like, what can it do? What are the permissions? And for this one, I would say just give it on project level, give it project editor rights that will allow it to create new deployments, create requests to it, and alter things. So that's the one you will need. If you've got too low permissions, you won't be able to follow the workshop. So make sure that you give it project and project editor rights. You can click assign. Okay. Then we can go to the next step, and there will be a token which you can copy and which will then be available. So let me exit full screen, quickly check the chat. No questions. Perfect. Okay, so once you've got your project set up and you've got an API token, then you're good to go to the Google Colab. So let me go to the Google Colab and share this screen. You can follow that. Let me again go full screen. Okay, so if you open the link I shared with you, you should see something like this, where you can again see a little infographic of what we're actually going to make. Every step there will be comments that explain what's going on as well if you want to read it back later. First things first, we need the UbiOps client library, so just run the first cell to make sure that that gets installed, so that it gets the latest version you need. Okay, there we go. And after that, we've got some variables that we'll be using a lot that we can that we just need to set up, and we need to set up a connection to the UbiOps API to make sure that we can actually start doing things. So that's what I'm doing here. So here I'm defining the project name. So at line number 5, make sure that you change this to the name of your project. In my case, that's Anouk demo project. Just to be sure, let me show you where you can also find this in the web app in case you forgot. So if you're in the web app, you can see here what your project name is. So in my case, it's a Anouk demo project. In your case, it's going to be something different. Make sure you get that project name and you put that here, that you change whatever value is here to your project. Okay. And then the other thing you need is your token. So if we run this cell, it will be prompted to enter your API token. So I'm just going to paste mine in here. And if everything went all right, you should see here status OK. And that means that a connection to the API client has been set up. And then we can continue to the next cells. So first, what we're going to do to be able to create our new deployment is that we're going to create a new environment. An environment basically dictates all the dependencies that your code has. So if you're using specific like Python packages or maybe even OS level dependencies that you have, which you could typically run into when you're using things like CUDA, we can prepare that environment so that we can reuse it for multiple deployments if we want to. So that's what we're going to do here. We're going to create a stable diffusion environment, which contains everything that stable diffusion needs. So you can run these cells. I've already made them, or not, I need to redo them again. I'm sorry. So let me do this. I'm going to make the environment direction or environment directory. And then here you will see 2 cells that have write file at the top. This will create the 2 files that we need with all the info for our environment. So that's in our case a requirements.txt, nothing special about that one. And a UbiOps YAML can be used for any additional OS level dependencies. So in this case, we need an extra index to be able to use the CUDA compatible version of Python. Okay, so let me also quickly run those. Okay, and now we can actually create that environment in UbiOps. What you can note in yourselves, because the free tier only has access to CPU and not to GPU, unless you contact us to add that. I've put this to use general Python 3.9. If you do happen to have GPUs already in your account, you already have an account with us, you can use Python 3.9 CUDA, and that will make sure that CUDA is installed, which is compatible with 3.9 and which will work with PyTorch. So if I run this, I probably will get a response that I already have one that's named like this. Yeah, I do. But you should see something that the environment is being created or that it's building. Okay, then you can continue to the next section where we will create everything that we need for our deployment. Because right now we've got this environment set up with all our dependencies and everything that we need, but we still need the code. And for here I need to send the files to the environment. So this uploads everything for the environment. And now we can continue to preparing the deployment code. So also for this one, I'm going to create a new directory in the Google Colab for everything related to my deployment, so with the deployment code. And then you will see another cell here called deployment code directory deployment.py. Deployment.py is what UbiOps uses to know what it needs to run whenever a new request is sent to your deployment. And this deployment.py has always a specific kind of structure, which is that it needs to contain a class called deployment. And in it, it needs to have two functions, or at least these two functions, which is an init function and a request function. The init function will be run whenever your deployment initializes. So this is great for keeping things in main memory, for instance, or loading quick things that you already need, just to make sure that everything's ready for whenever a request comes in. And the request function, which you can see here, is what actually will be executed when data is sent to your deployment. So this is just a template. Basically, you can put any kind of Python code in here that you want. It just always needs to have this structure. So in our case, what we're doing is we're getting the stable diffusion pipeline from the diffusers library. Diffusers library is from Hugging Face. You might have worked with it yourself. And what I'm doing in the init function is just loading this pipeline so that it's already ready for whenever new requests come in. So that's what I'm doing here. You can see self.pipe is stable diffusion pipeline, yada, yada. Okay, and also here I check if there's actually a GPU available. Because as said, for your free account, you can only do it on CPU. So but I made this code to be able to work with both GPU and CPU. So the code just checks, is there a GPU available? And if not, then just continue with using CPU. And the request function is very simple because of this. It's just running the data through the stable diffusion pipeline. And the way we do that is by retrieving our prompt from this data variable. This data variable is a data dictionary that is passed to your model whenever data is sent to the model. So this will have keys for every kind of value that you have. So in our case, we only have the key prompt. And if we retrieve that from the dictionary, we will get the actual prompt that someone sent in. And we can pipe that through the stable diffusion pipeline. We save the image and we simply return the image in the return statement. So if you run this, it will create that as a deployment.py file. And then we have enough to create our UbiOps deployment. So what we can do is here you've got this deployment template that you need to fill in. Every deployment, basically how deployments are structured is that you have a general deployment that can have multiple versions. So the deployment just has a name and defines how the input and the output looks. In our case, we've got one input field called prompt, and it is of data type string. And we've got one output field, which is called image, and it is of data type file. So that's really all the information that is necessary for the deployment, and the actual implementation will come in the deployment version that we will create for it. Now, I've already created this deployment, so I will not run it again because I'll just get an error that it already exists. If you run it, you should see something like this. So the creation date, description, what project, etc., just to make sure that everything went all right. If you've got that one ready, you can make your version. So here I've set yours to use 16 gigs. And that will just create a 16 gig CPU or CPU-based instance. If you want to work with GPUs, I would recommend using the 16 gig T4 one, because that one is better optimized for this one. With the T4, it's about 10 seconds, the request time. With the 16 gig one, it takes 6 to 8 minutes. So that's quite considerable. But that's just to make sure that it could fit on the free tier so you could try it yourself. And then here you can see two values for the maximum and the minimum number of instances. These are the parameters that UbiOps needs or uses for scalability. So in this case, we can only scale to one instance. But if you actually want to deploy something, you typically would want to set this to a higher number to make sure that when the data traffic is very high, more instances can be spun up so that these requests can be handled in parallel, so that it can be done quicker than when they just fill up in this queue. And the minimum number of instances is how far we scale down when the model is not used. In this case, it's set to 0. That means that the model is completely turned off while you don't use it. And this also makes sure that it doesn't use up any of your resources while you're not using it. But this does increase or add a cold start the first time you use it. So you can also just run that once you're ready. As you can see, I already did it. I already made one. And then you just push the code to UbiOps. So that's what this one does. It zips it up and pushes it to UbiOps so that the code is also available on UbiOps. And your deployment will first need to build a little bit. So to make sure that you wait until it's available, you can use this function, run this cell, and once it's available, it will return deployment version available. And in the meantime, it will just say that it's building. And once it's available, you can actually create requests through the model API and UbiOps to make predictions. So let me quickly go to the web app to show you where the model is. So here I've got mine. You can see I've got a couple of versions. I can create requests in here as well, but I'll just show you how to do it with the client library. So let me just go to the request tab so we can inspect it later. There we go. Okay, so let me send a prompt. So I've got this prompt for a green dragon portrait. So let's send it over. I hope it was still warm, otherwise it will need to spin up, which will take a little bit. And then once it's ready, we can download the response and have a look at that. So while that is running, let me quickly check the chat. Getting an error in creating environment. Can you share the error that you got? Oh, I can see that you could not see the website. I'm sorry, I must have missed to press the button. Should be able to see it now. Yeah, there you can see it. Okay, so what I tried to show is that I've got the model right here. So the Stable Diffusion one that I already had deployed. And I've got here one that uses a T4. And when I make a request, it comes up here. So after I run the cell to create the request, you can also see it being added here in the request stable, where you can also have a look at the logs to see what's actually happening in the background, so you can see what it's doing. Okay, so I hope that now you could see what I was doing. Yogesh, if you can share the error that you got in creating the environment, that would be great. Then we can have a look at that and what's going on. And let's see, for the Colab, you can simply use the CPU. It's fine because we won't be training a model in the Colab. Everything's being sent and processed by UbiOps. So there's not that much of that is actually being processed by the Google Colab. So you don't necessarily need that. You already figured out the error. Perfect. Okay. That's that. Then, yeah. Okay, let me switch to this one. Because if everything works all right and you run the last 2 cells for showing the results, you will see the result that actually came back from it. So in this case, like we've got this red dragon that's coming up. It's looking a little bit funky. The thing with Stable Diffusion is that every time you run it, even with the same prompt, it will come back with a different image. So it might be that if you get a really weird one and you just run it again, you'll get a nicer looking one. As said, it might take a little while for the CPU one because it requires about 6 to 8 minutes. You can follow the progress in the web app. So if you go to the logs, you can see what's going on. Or if you or if you go to your model, so you will see it in the deployment Stable Diffusion. You can go to the one that you've created and check the requests tab as well to see what's going on. So in this case, you can also see it here if it's done. And once it's done, it will be put on the storage bucket that's always readily available in every project, which is just a general Google Cloud Storage one. You can also connect it to your own storage on S3 if you want, or anything that's MinIO compatible, or S3 compatible, sorry, like MinIO. If you want to have it in a specific location, you can also do that. But for now, it will just end up in the default bucket, and you'll be able to download your results from here or view it in the Google Colab by running the last lines of code. Okay, and that's basically the example. And I see that we finished right on time, that we still have 10 minutes. There were a couple of questions I saw that I hadn't really fully answered yet, so let me quickly scroll back to them. Okay, so the first question about the one with Kubeflow and MLflow, I hope I answered. Omar, is that question how do you say it, sufficiently answered, or is there anything else you're still wondering about? Please let me know if so. And then you also had a second question about how do you do shadow deployments? Is that just logging to see how the model is performing? So how you do shadow deployments depends on what kind of platform you're using. How it works specifically, some platforms sometimes have specific settings for it. Sometimes, like if you're using fully open source ones, you typically have to set it up yourself. I can quickly show you how it works in UbiOps. And let me see, do I have it in this one? Pipeline here. I can show you here. Okay, so in UbiOps, we've got something called pipelines, which are basically bigger workflows made up from deployment. So let me go to this one just to give you an example. So here you can see a pipeline where I've got 3 deployments. Each block is a deployment. And I'm doing some stuff in between, but that doesn't really matter for answering this question. Let me show you what I would do in case of a shadow deployment. So here I've got a specific frame processor deployment because this is a video processing pipeline. Doesn't necessarily matter. This is just a specific ML model I have. You can see it's using V2 here. Now let's say I made a different version and I want to deploy it as a shadow deployment so I can just see how it's working. What I can do is get that frame processor, drag it in again, but now use a different version. So let's say I use the default version, and let's assume that that's a different one. And I also want to run that one. So what I can do is I can connect these 2 up. So I connect it to the same source so that everything that's being sent to the other version is also being sent to this one. And then what I can do is also is just not connected to end. So instead of, so I will be able to see the output of this whenever I make a request to this now. What will happen to the data is the data, like the video, will go to the video splitter first. It will then split everything up into frames, and each frame will go through the frame processor, and it will go to through the 2 different versions of them at the same time. So one in shadow mode and one is like public. Only the one that I had previously already deployed is then connected to like the rest of the pipeline and to the end. This one is not. And what that allows me to do is that if I send a request to this, and I inspect the request, I will be able to see the input and the output of this block, even though it will never be outputted via the API. So anything that's subscribed to that API endpoint or uses that API endpoint will not be bothered at all by what this shadow deployment is doing. But behind the scenes, I will be able to see how this deployment behaves and if it is as I expected. And by having something in shadow mode like this, you can basically see already how it works in a production setting without actually having anything that uses the API be troubled by the fact that that one's there. So I hope that answers your question a little bit. Let's see. Copy of the slides, I already had that one. Can you please show slides rapidly? I'm not entirely sure what you mean. A specific slide that you want, please let me know if there's like a specific slide or anything that you want, then I can go back to that. Pipelines remind me of Azure Data Studio. Lol, question, are there pipeline templates we can use, or do we have to manually make one in the beginning? So we've got a lot of blog posts with some examples that you can use. So for instance, this video processing one is readily available. I can share the link in the chat in a minute. And a lot of other blog posts with examples. And we've also got a full repository with notebooks that deploy pipelines for you so that you can see how they work and adjust them. So things like retraining pipelines, for instance, or champion challenger setups that we have. So yeah, there are always templates. You cannot load them in from the web app if that's what you want, but we've got a lot of examples that you can use. What should I use for the API token? So let me quickly exit this and not save it. So if you want the API token, just scroll to project admin, go to, let me go to full screen so it's a bit easier. Project admin, go to permissions, and then to API tokens and create add token. And in the role, make sure that you assign project editor role. This should also be written in the text in the Google Colab. So, but this is where you can find it. Okay. Then question, would this be a considerable overhead even though the user never sees it on the pipeline just to get logs, etc.? So that's for the shadow deployment. No, not per se. It depends on how you set it up. So in the deployment or in the pipeline, if you like always have it there and you make the end of the pipeline wait for every block to have finished processing, then yes, that would add some additional overhead because the pipeline will also wait until the shadow deployment is done, which can delay things. However, if you can also set it up in a way that it doesn't necessarily wait for that until it gives that last response, then it's fine. Or if you've got a longer pipeline in any case where like there are multiple steps that need to be done afterwards that you won't connect that shadow deployment to, then of course it doesn't matter because everything will be run in parallel on separate pods and will be scaled separately. It's not that the pipeline as a whole runs on one machine. It's really like every node of the pipeline is scaled separately. So you shouldn't really notice it in the end because most likely it will be quite similar in performance as the block it is mimicking. So as long as it doesn't exceed that one too much, it doesn't really add any overhead because it's handled in parallel. Just click slides, please, to see the first one. I came late, was not here for the 20 minutes. Thanks. Yeah, okay, I will do that in a bit. First, the other two questions. Maybe a naive question. Does UbiOps have its own servers to an extent, or does it always use other cloud servers? So definitely not a naive question. So we've got the UbiOps SaaS, which generally works or runs on Google Cloud. So there we don't have our own servers that you actively deploy on. Like we've got some, but those are not exposed. However, we also have some available in some European specific clouds that people can also use. Also with the SaaS, which is, for instance, with BytesNet, and just to name one, which is like a more sustainable cloud, or T-Systems. And it's also perfectly fine to use, like if you've got how do you say it, like on-premise servers, so you really have your own servers and you want to use UbiOps on that, that's also perfectly possible. Then we can do an on-premise installation, but then you will just not use the SaaS. And then we install it really on your hardware. So we've also got some customers that have that typically when they have regulatory things. How does UbiOps play with third-party apps like Airflow? Okay, so third-party apps like Airflow, what you can do, like Airflow, of course, can run a lot more than just Python and R. They can really run basically anything. So what you can do is hook Airflow up to UbiOps by using like the client library, for instance, if you would want to. This is not necessarily something I have explored personally because a lot of the functionality kind of overlaps, but is also kind of different in other ways. So typically what we see is that people just kind of hook them up where they need to be using the API endpoints and not really more than that. Okay. And I see that I ran out of time. I will still share the link for the one article I mentioned, and I will check out how I can get the slides to you all so that they can be shared with you so you can look at them in your own time. That also goes for you, Ayla. Sorry, I don't have the time to go through them now. And so I'll just share the slides and then you can go through them in your own time. That should hopefully be fine. Thank you so much for your attention. I hope it was clear. And the last thing I just wanted to say is visit us at our booth if you're here tomorrow or the next day, because I will be there physically with a colleague of mine. You can find us over here. Yeah, look forward to meeting you all, hopefully in person as well. And thank you so much.